Hello and welcome. Today we're going to start a series on ignition systems. This is one of the most misunderstood parts of the whole build, and I think it's a good idea for you guys to understand all the way from the stator to the ignition coil what's going on. We're going to be working both with the OEM ignition system and with the new Zeeltronic ignition system to give you an in-depth view at how the systems work, how you can make them work better for yourself. So let's get into the shop. Okay, so as you can see here on the bench, we have both an OEM stator on the left and a RIX stator on the right. Now the OEM stator is still set up to work with the OEM CDI boxes. The RIX stator on the right has been floated so that it'll work with the Zeeltronic. Now, what is the difference between a landed and a floated stator? Well, let's take a look at how the two systems act with their connections. So in this very crude drawing that I've made, I have a representation of the stator coil as it is for an OEM ignition system and the stator coil as it needs to be for a Zeel ignition system. On this side, you can see that one end of the coil is connected to the chassis, the straight lines representing the chassis, or what we would call a ground, but the chassis is not really a good ground. It is a shared plane, but it's not really a good grounding system, okay? One end, though, is opened up, which is the black wire with the red stripe, and that goes to the CDI box. On the other side, we have the Zeel stator, which is both ends of it set above the chassis or above the shared plane, the grounding plane. So let me give you a practical example of how to test for this and what it actually means. So we're going to take a multimeter and we're going to set it to ohms. Then we're going to insert one of the probes into the black wire with the white stripe. And then we're going to take the other probe and we're going to touch the casing of the stator. Now this is saying about 190 ohms, okay? But watch what happens when we come down and we touch the table. Well, there's the 190 ohms. That means that one end of this coil is attached to the body of this stator, which then is obviously bolted to the aluminum piece that mounts it to the motor and then to the motor itself. So one leg of this is attached to the chassis. Okay, now that works in an analog ignition system, which the original 250Rs, all the 85 through 89 250Rs use an analog CDI box, but doesn't work once we get to digital ignition systems, and I'll explain that here in a little bit. But now let's test the stator that has been set up for the Zeeltronic. Okay, now we have the RIX stator that has been configured and wired to go onto the Zeeltronic, and what you will see on this is actually two red wires. Now because this is an AC signal, it doesn't matter what its plug location is in this middle right here. That doesn't mean anything because it's AC, so we could swap these around. It wouldn't make any difference to the CDI box. But let's probe this and see what happens. So we're going to put this onto one of the red wires and then we're going to touch the chassis. You notice there's no read there, no read through its mount, no read down to the plane. But if we put it into the other red wire, then we see 183 ohms. So this stator sets above its ground field or above the unified plane. Now, let's talk about this for a second because there's always this big misconception of what this number should read, whether it is on this stator or on the OEM stator. So let's go straight to the Honda printout and look that right here it says exciter coil resistance can be between 50 and 250 ohms. Pulse generator coil resistance, This is the pulse generator right here, which would be represented as a blue wire with a yellow stripe and a green wire with a white stripe, or on the ricks as a blue or green wire. Can be between 50 and 200 ohms. With the lighting coil resistance, we'll just go over this, can be between 0.1 and 1 ohms. So we can see a number inside of this range anywhere, and both the OEM CDI box and the Zeeltronic CDI box will perform. So you can use a multimeter in the field to get a good idea if either one of these coils, lighting coil, ignition coil, or exciter coil, has opened. And when I say opened, I mean that the wire has become disconnected in some sort of a way. Also, on a Zeeltronic ignition, if this stator or the OEM converted stators happen to get flooded, as people allow their stator covers to fill with water, if it gets flooded, it can create a short between the coils and the body. So if you have an ignition system that's not working right and you pull the stator cover off and there's a bunch of rust or a bunch of water has come out on a floated stator, go ahead and test once again in between one of the red wires and the body of it, and if you see any amount of signal, so let's say we saw an ohm, 2 ohms, 300 ohms, whatever, then that means that this thing has become internally shorted because of the moisture. Now, sometimes you can take them and put them in front of a heater. You can put them over forced air heat and let them dry out for a while, and they'll go back to working correctly, and sometimes not. But that is something to try before you bail out and buy another one from one that's been deluged with water. One other thing to go over on the floated rick stators is that the lighting side of the coil, which is going to be represented here as a yellow wire, is still connected to the unified plane or the ground. So if we turn this on, we can see that if we're going from the yellow wire, probing the yellow wire, and then going to the body, we're going to see 0.6 ohms, okay? Going down to the unified plane, we're going to see 0.64 ohms, all right? So the lighting coil side of this is going to act just like it did as OEM. So let's go over the wires too. Once again, we've got a green wire and a blue wire, and these are the exciter coil or trigger wires. We have 2 red wires, which are going to supply the voltage to the CDI box, and we have a yellow wire, which is going to supply the voltage to the headlights. On an OEM stator, we're going to have a green wire with a white stripe and a blue wire with a yellow stripe. We're going to have a black wire, and these are going to be our exciter or our triggers. We're going to have a black wire with a red stripe on it or red dashes, and that is going to be the one leg of the AC. And then we're going to have a white wire with a yellow stripe, and that is also going to be one leg of the AC for the lighting coil. Once again, if you probe between the white wire with the yellow stripe and the housing or the unified plane, you're going to see a reading between 0.1 and 1 ohms. Now, this one actually has a damaged lighting coil. So we're going to probe in here like this, and then we're going to touch on the housing, and we're going to see that that is in the milliohm scale and very unstable. So something has gone wrong with the lighting coil on this, which I'll need to dismantle it, unwind the thing, and figure out where the problem is, and then rewind it. All right, let's move on to the next step. Now, some of you will be asking the question, how do you float an OEM stator? Well, the simple answer is, if you hold the stator in this orientation, you can see on a lot of them that there is a winding coming off of this coil, and it is attached to this pole right here that sits underneath this ignition coil, okay? This has to be cleaned off and unwrapped from here very carefully, and then attached to a wire that comes out through the harness and brings the other side of this coil leg out as floated, so that it's no longer attached to ground. Now, the wires that these things are wound out of are 7/1000 of an inch in their cross section, which means that they're 3 times the size of a human hair. So it's really easy to damage, but it can be done with some patience and the right tools. I would like to thank the sponsors of the show, Mod Quad Racing and CP Industries. Mod Quad Racing is the finest manufacturer of aftermarket billet parts, and their website is too large to list here, so go check them out. CP Industries is the largest manufacturer of ATV cylinders in the United States, and they hold all the speed records in drag racing. Either one of these companies can help you out. If you contact them, let them know I sent you. All right, let's get to the tutorial. All right, we're going to start with a PSR B10T, but this will also be applicable to the 11T and a lot of the different models that Zeeltronic offers. Now, I don't have one that has not been wired up. Everything I have here has connections on it. So we're going to go over the wires that are necessary for your 250R to run, and the extra wires that are not used, I will explain what they do when we get to the software section of the thing. So here's what the important thing is to know. When attaching these wires, and if you decide to put your own connectors on, go to cycleterminal.com, he's out of Florida, and buy good connectors. Do not cheap out on your connectors, because if you do, it is going to cause problems downstream, okay? I cannot stress that enough. Use good connectors and use the proper crimper to not have future problems. All right, so we can see that in the wiring harness, there is a green wire with a white stripe and a red wire with a white stripe, and then a green and brown wire, all right? So this is what's important. Now, I'll put up a close-up picture of the orientation that I use in the wires. So if you wire it, it's best to stay with this wiring configuration that I have come up with, because if anybody has one and you're having problems, you can just unplug the one that you wired up into the one of them that I wired up or that Weston is wiring up, and they'll work all the same. All right, so the most important thing in this is making sure that from the stator, the green wire is attached to the green wire with the white stripe. So green to green. The blue wire will be attached to the red wire with the white stripe, okay? And then the 2 red wires here off the stator will be attached to the green and brown wires. And it doesn't matter, once again, because this is AC voltage coming in, it doesn't matter how these orient this or how these occupy this middle position, because it's AC. So either one of these can be to either side. That's not going to affect it. All we've got to do is make sure that each of the red wires is connected to one green wire and one brown wire. And then that completes our circuit. Now, there is a problem that I've run into on a few of these, the aftermarket ones, which is that the exciter coil is actually wired backwards or wound backwards. And I'm going to have to describe, I could drag down the oscilloscope, but I'll make another crappy drawing and show you what we're looking for. Okay, the way the OEM ignition system and the Zeeltronic wants to see a triggering signal from the trigger, this being the trigger, is that when it passes the tab, the signal first goes above 0 and then below 0 and then returns to 0. If this has been wired correctly, if this has been wound correctly, so that green is the leading edge and blue is the trailing edge, then this is what we should have. In which case, the Zeeltronic or the OEM ignition system will know how to interpret the data correctly. On the other hand, if these Chinese triggers have been wound in reverse, what happens is both the OEM and the Zeeltronic will see the negative pulse first and then the positive pulse, and they don't know what to do with it. They will start and run, but they're going to be extremely out of time and the curve won't work, and it's just, you'll fire it up and you'll think the thing's running, but it runs like crap, okay? Now, if you go ahead and buy a kit from Cycle Terminal, get the remover tool for these, because in a lot of situations, that's the problem with aftermarket CDI boxes or aftermarket stators, and what you can do is pop these two out and just switch their location and plug them back in and see if that cures the problem. I've cured a lot of aftermarket ignition systems by just flipping the trigger switches, okay? So if everything is working right, always green from the stator trigger to green with the white stripe on the input, okay? Or green with the white stripe on the OEM input. All right, let's move on to the next. Okay, so for representation's sake, we're going to take the stator and we're going to set it on this box. That way we can visually see that it is isolated from this unified plane. No part of it is electrically connected to the unified plane, with the exception of the lighting coil, but that's not going to be taken into account. Now we're going to plug these together, and this is floated stator into the Zeeltronic. Now we have both our trigger signal and we have our voltage coming in, which this voltage that's coming out of here, once again, is an AC signal, but it is rectified and regulated once it makes it into the box. So it turns from AC into DC, and that is the big difference between an analog ignition system and a digital ignition system. To be able to run a microprocessor, we have to get this incoming voltage into something that a microprocessor can deal with, which is going to be a DC signal or a DC power supply. Okay, the next wire that we're going to turn our attention to is going to be the orange wire, and this is going to carry one side of the higher voltage that is going to trigger your coil. And it is my procedure to put the orange wire on this green tab, just like that. Make sure it makes a good connection. And then the way that I wire up these, and Weston also, is that there is one black wire coming from the Zeeltronic, and that is its ground. And on there you will see one ring tongue and one of these flat connectors that connects to the back of this. And this is going to create the signal, the incoming signal for the coil. Now, I see this all the time online. People are like, oh, I think I burnt up this coil. I'm going to tell you that in all the years I've been doing this, I have only seen one burnt up coil, and I did that by over-voltaging the thing in the early years when I was experimenting with building my own ignition systems, and literally smoked the thing where it was burnt up. Okay, so if you're using this type of an ignition system, it does not put out enough current or voltage to burn these up. Burning one of these up is very rare, so I always tell people, if your ignition system has gone bad, this is not the first place I would start looking, okay? So we've got black wire to the back of this onto the black, and orange onto the green, okay? Now, the next and only last wire that it takes to make this work is to take this wire right here that has the ring on it and ground it to the chassis. or more importantly, ground it to the motor, okay? One of the problems that we've had with the Zeeltronics is that if there is not a good ground path from wherever this is connected to the chassis to wherever the head is, so let's say there's a certain amount of resistance between the top of the cylinder and the chassis, even if it's small, it will cause the microprocessor inside of here to burn up, all right? So my thing is if you're going to connect this to the chassis, also run a ground wire from the cylinder to the same exact area. I try whenever possible to bring this right to the engine to get the best grounding source possible, okay? At this point, when this thing is excited by a magnetic field, it will produce voltage and a trigger signal, and the ignition system should work. None of the rest of the wires need to be hooked up, and we'll go over what these are here in a second, but none of the rest of these wires need to be hooked up. What needs to be hooked up to make this thing work? This needs to be plugged in, black wire to the back of the coil, orange wire to the back of the coil, and this grounded to the motor. At this point, it should be producing spark. Okay, now, if you want to kill the motor as it's running, you need a grounding type switch, which means a tether switch that when you pull it, it shows ground, or it shows a connection between itself, or a push button switch that if you measured it with the ohm meter when it was at rest, there would be no signal going through it, and when you push it, then the signal would be connected, okay? So this here needs to hook up to one side of that switch, and the other side needs to be attached to the chassis or to the motor, okay? Then that'll give you your kill switch. Then in this one, we're going to have a brown wire with a green stripe, and this is going to be the input lead for the map switch. Once again, you need a switch that is open in one position and closed in the next position. Open where the contacts are not touching, and closed where the contacts are touching. And that would plug in between this right here, which is another black wire, and this right here, because when this is shown ground, so when this circuit is completed, this will switch to map 2. When it's open, it will be on map 1. So with your switch, when you switch it, and we use like the little motorcycle kill switches, when you switch it on, it will connect this or complete this circuit, and that will put it on map 2. When you switch it to off, it goes to map 1, all right? So that is the wires that you need to make this thing work from a wiring standpoint. I cannot stress though how important it is to make sure that that ground is as solid as possible. Now, for people who don't want to run the ground to the motor, run a good ground strap from the motor, a clean aluminum part from the motor, over to the chassis, which has a clean part that it can get that it is attached to, and then attach this to it also, okay? But this needs to have a very good ground as to not damage the processor inside of this. All right. That is as simple as it is. There are some people out there that make it a lot more convoluted than this, but that is literally as simple as it is. Now we're going to move to a testing phase so I can show you how this actually works on my ignition dyno. Okay, so when I say ignition dyno, what does that actually mean? Well, here's the components that it takes to measure the things that we're looking for. In this case, I just machined down half of a case and made that as my base plate for holding this stuff, okay? Then you're going to need something to turn it with. Well, what I used was an angle head grinder that will turn up to 11,000 RPM, and then a variac that was actually built in 1921. It was actually given to me by a friend whose father was a prop master in Hollywood, and according to him, and I don't know if this is true, but that was used on a bunch of old like monster movies and stuff like Frankenstein. I don't know that as a fact, but it definitely looks like something out of that era and time. Okay, so then Digital oscilloscope is not 100% necessary, but it's extremely helpful. And then some sort of a timing light that can be triggered off of this ignition system. Then over here I have built a small Arduino that uses a magnetic switch to power an RPM meter, so I know exactly how fast I'm turning this. On the other part of it too, having a laptop when you're working with a Zeeltronic ignition system is going to be quintessential to make everything, to do all your programming changes. So I built this back in the 80s, and I've built, over the years, I built one of them for a buddy of mine, John, and then I built, a few years back, I built one for Arlen, which is a lot nicer unit than what this is, from LED, when he was having problems with people saying that the HPI ignition systems weren't working correctly. And I built one for him so he could bench test them there and see if there was a problem with them or if people were just hooking them up incorrectly, which came out to 99.9% of people hooking them up incorrectly. So let's get the ignition box plugged into this and run through what it is I'm looking for. Now, I talked about the leading edge and the trailing edge of the trigger, so I thought I would go ahead and hook that up to the oscilloscope so you can see what it looks like when it's correct. And before I had said the green was the leading edge, but that is incorrect. The green is the trailing edge. So this is what the signal going into the Zeeltronic needs to look like to be correct. Now, if we switch the probes around, what's going to happen is we're going to get a signal that is inverse to the one that we just saw. Let me hook this up here. And now we'll turn this on. And you can see in this example that the leading side of it now goes below zero with the trailing side going above zero. And that is opposite of what both the OEM and the Zeeltronic ignition systems are looking for. One other piece to the puzzle is you're going to need to have a flywheel that has been indexed for degrees before top dead center, and I marked mine 10 degrees after top dead center also. This can be done on a rotary table in finding top dead center, which is indicated by the T on the flywheel, and then just go ahead and make hash marks. I did short hash marks for 1 through 4, with 5 being a larger hash mark, and then the ones that go across are graduated in 10. So that's something else that you will need if you want to do this and get some good repeatable accuracy in numbers. Now, one thing that cannot be overstated, always, always, always use resistor plugs. Unless you want to damage your digital ignition system or your camera. So always use resistor plugs. Now, what I'm going to do, and I've turned off the lighting in the shop, and I just want to turn this on so you guys can see the spark from the plug. So that's a spark output that we're looking at right there. Now what I'm going to do is show you how I determine what the timing is actually doing. Not just what the computer says it's doing, but what it's actually doing. Now, because of the rolling shutter effect and the strobe light, you're going to see a line that comes through the image as I'm using the strobe light on it. There's really no way to get around this with this type of a camera, so just bear with it, but I think you'll be able to see what it is that I'm looking at. So I'm gonna go ahead and start the thing up. And with the monitor turned on, it's telling me in the software that I'm at 10.9 or 11 degrees, and that's what I'm seeing on the physical flywheel. Now I'm going to go ahead and push it up a little higher in RPM. You can see it drift over. Now I'm going to push it up into its retard curve and watch what happens. That's what I'm looking for to make sure that what the software says the engine is actually seeing. Okay, this completes the hardware section of the tutorial. But if there was something that I missed in there or you didn't understand it, put your questions or comments down in the comment section and I'll read through that. And when I do the next video, which will be on the software side of the thing, I'll go ahead and address those questions so that we can get some clarification. After that, we're gonna do troubleshooting and try and figure out why so many people have problems with ignition systems. So stay tuned and thanks for watching.